Imagine a quiet night, the universe humming softly above. For decades we've listened to the cosmos, searching for a pattern, a message that might prove we're not alone. In 2019, deep in the Australian outback, a telescope caught something extraordinary, a faint, pure signal cutting through the static. This wasn't random cosmic noise, it was orderly, focused, and seemed to come from our closest stellar neighbour. The news spread quietly among astronomers, sparking disbelief and wonder. Could this be it? After years of searching, had we finally heard a greeting from another intelligence? The signal pointed directly at Proxima Centauri, just over 4 light-years away, our cosmic front porch. Orbiting that star is Proxima b, a planet in the habitable zone, long imagined as a possible home for life. The idea that a signal could come from a world so close was almost too perfect. For several hours the signal held steady, a narrow, focused beacon in a sea of randomness. The Breakthrough Listen project team knew they had something special. They called it Breakthrough Listen Candidate 1, or BLC-1. It was a clinical name for a discovery that felt anything but. This whisper carried the weight of our hopes, dreams, and cosmic loneliness. The journey to understand that whisper had just begun. Humanity's oldest question, are we alone, suddenly felt closer to an answer. The world held its breath, unaware of the secret being unravelled. The search for meaning in that signal was underway. To grasp the weight of this discovery, we must visit Proxima Centauri. It's a red dwarf, faint and cool, part of a triple-star system just 4.24 light-years away, our next-door neighbour in the galaxy. In 2016, astronomers confirmed a planet there, Proxima b. Slightly more massive than Earth, Proxima b orbits in the habitable zone where liquid water could exist. That's why we listen. SETI, the search for extraterrestrial intelligence, scans the skies for signals that stand out from cosmic noise. Natural phenomena create messy signals, but a technological civilization might use a narrowband, focused frequency, a cosmic lighthouse. Proxima b, rocky and nearby, became a prime target. If life arose there, their signals would be easier to detect than those from distant worlds. We listened, hoping for a single, clear note in the universal static, a sign that someone else might be out there wondering the same thing. In April and May 2019, the Parkes Radio Telescope in Australia scanned Proxima Centauri for Breakthrough Listen. For weeks, the data was routine, until a new signal appeared. It was a narrowband emission at 982.002 MHz, the kind that makes SETI scientists take notice. This signal, BLC-1, persisted for hours, only appearing when the telescope was aimed at Proxima Centauri. When pointed away, the signal vanished. When aimed back, it returned. This nodding test ruled out most local interference. The signal's frequency drifted slightly, just as you'd expect from a transmitter on a moving planet. Every clue fit, a persistent, drifting narrowband signal from our nearest neighbour. The team, led by intern Shane Smith, knew they had to be careful. SETI's history is full of false alarms, but BLC-1 survived every initial test. It wasn't from a known satellite or natural source. For a brief moment, it was the most promising candidate for alien technology ever detected. The discovery was kept secret as the real work began, proving it wasn't a dream. The world didn't know it yet, but the search for confirmation was on. The possibility of first contact felt closer than ever. The next steps would demand extraordinary rigour. Within the SETI community, BLC-1 sparked cautious excitement. The data was compelling, the source close, and the implications enormous. Dr. Andrew Siemian, Breakthrough Listen's principal investigator, called it one of the project's most intriguing signals. For these scientists, it was a chance to validate years of work and skepticism. A confirmed signal would mean SETI's long quest was justified, but hope was tempered by responsibility. Extraordinary claims require extraordinary evidence. The team began a slow, painstaking process of verification, ruling out every alternative explanation. They lived in suspense, holding a secret that could reshape our world. Late-night calls, encrypted emails, and a shared sense of history in the making defined this period. The signal from Proxima b was more than data. It was a beacon of possibility. For a short while, those who knew felt humanity might not be alone. That glimmer of hope was powerful. The investigation became a cosmic detective story, with BLC-1 as the central clue. The first suspect, ourselves. Human technology floods Earth with radio signals, creating endless interference. The team, led by Sophia Sheikh, sifted through mountains of data, re-examining every test. Was the signal truly from space, or just a trick of terrestrial noise? They searched for similar signals, looking for a pattern that might link BLC-1 to human technology. Sophisticated algorithms scanned for matching bandwidth and frequency drift. The process took months, stretching into more than a year. Every anomaly was scrutinized, every lead followed. The central question remained: was this a voice from another world, or just an echo of our own? After a year of exhaustive investigation, the truth emerged. BLC-1 was not a message from Proxima b, but radio interference from Earth. The team found dozens of similar signals scattered throughout the data. Local interference, not an alien beacon. The signal was traced to common electronic devices, specifically an intermodulation product, a distortion from mixed radio frequencies. The frequency drift, once so promising, was caused by a warming oscillator crystal in nearby equipment. The alien message was likely just the hum of a poorly shielded device. For scientists, it was a moment of disappointment and pride. The hope for discovery faded, replaced by a mundane explanation. Yet the process was a critical lesson in the search for life. The journey wasn't a failure, it was a necessary step in learning how to listen. The debunking of BLC-1 was sobering, but it brought valuable lessons. The event became a dress rehearsal for first contact, stress testing every protocol and tool in SETI. Sophia Sheikh's team set a new standard for future investigations. The main obstacle in the search for extraterrestrial intelligence is our own technological noise. BLC-1 showed that to hear the universe, we must quiet ourselves. The experience strengthened the scientific community's resolve. The search for life was never going to be easy. It demands patience and scientific rigor. The story of BLC-1 is one of resilience, not failure. Science is a self-correcting process, embracing uncertainty and truth. The silence from Proxima b was not an end, but a new beginning. Today, the search for life beyond Earth continues with renewed clarity. The story of BLC-1 is a foundational lesson in SETI, a cautionary, inspiring chapter. Proxima b remains intriguing, but its violent star may make life difficult. Our search is evolving. New telescopes like James Webb will analyze exoplanet atmospheres for biosignatures. We're moving from listening for messages to looking for chemical fingerprints of life. Meanwhile, our own radio signals have already reached Proxima b, announcing our presence. The quest is twofold. We search for them, and perhaps they search for us. The universe is vast, and we've only just begun to listen. The story of BLC-1 teaches humility and perseverance. The desire to know if we're alone connects us to our ancestors who gazed at the stars. The search continues, not just for answers but for what the search itself brings us. The sky is full of possibilities and questions waiting to be answered. We will keep listening, keep looking, and keep dreaming.